Alright, this question that you have been on the screen happens to be a NECO question, and I want to show you how to solve this problem. And I want us to look at what the question says first. And the question says that an elevation of a lantern is shown below. Question A says copy the given view full scale, and question B says draw Roman figure 1, the plan in first angle projection. And Roman figure 2 says a complete pattern development of both B and C together. So that is what the question says. Now let's look at the diagram itself. As you can see on the screen, this diagram has two parts. So this is part B and this is part C, and then we have the base here. The base here is a square, so it's a square, and this length or side of the square is 40 millimeters, as you can see on the screen. Likewise, the top here is also in a square form, and the length or side of the square is 64 millimeters. Now if you look at this diagram very well, if this base is a square and the top here is also a square, it means this is an incomplete, this part C is an incomplete pyramid, is an incomplete square pyramid. Likewise, part B also happens to be a pyramid which is complete. Now the height of this part C, which is a square pyramid, or this part C is a frustum of a square pyramid. So let me clarify that. It's a frustum of a square pyramid. A frustum is a three-dimensional object that is cut, whose part is cut off. So the part of this normally is supposed to be a complete pyramid. We're supposed to have something like a triangle, but part of it has been cut off. So meaning that the remaining part that we have here is a frustum of a square pyramid. While this one is a complete pyramid, that is part B, is a complete pyramid. So the height of this pyramid, that is part B, is 15 millimeters. Also, its base is also 64 millimeters. So the square base of this part B also has a length of 64 millimeters. So I want to show you how to solve this problem. And before I begin to solve this problem, you are watching my video for the first time, you have not subscribed to this channel, you need to subscribe. If you happen to be a technical drawing student, subscribe and share my video with your friends. Don't forget to put on the notification bell so that whenever I upload a new video, you will be notified. Now let's go and solve this problem. Now the first thing that you need to do is that draw a center line. So draw a vertical center line here. So draw a vertical center line. And down here, draw a horizontal center line. And then, so the first thing that I want to do is that I want to draw the front elevation first. I want to draw the front elevation. This shape that we have here, I want to draw it first. So I will still leave this one, and then I will move up and produce the front elevation as given to us in the question. So what we have here, just draw a horizontal line here. So draw a horizontal line. So and then we have that. So the square base, or the base of the part C, the length or side is 40 millimeters. So from the center here, take 20 millimeters to the right and 20 millimeters to the left. So as you can see here, then we take a measurement of 50 millimeters up from here, a measurement of 50 millimeters, which is the height of part C. So take 50 millimeters up and come up here and draw a horizontal line. So draw a horizontal line like this, and don't forget that the square on top of part C is, the length on side is 64 millimeters. So 64 by 2 will give us 32. So take a measurement of 32 millimeters to the left and 32 millimeters to the right. Then, so we are going to join this together. So we have to join this together. So join this together with this, and then you join this together with this, and then so we join this together with this, and we join this together with this. All right, so to now draw part B, so that is part C. So to draw part B, we take a measurement of 15 millimeters up, because the height of that is 15 millimeters. It's 15 millimeters. So we join this together. So we join this together like this, and then we join this together. All right, so with what I've done here, I've drawn the front elevation as given to us in the question that we should draw the given view. So I've drawn the given view. So the next thing that I want to do now is that I want to answer question B Roman figure 1 that says that we should draw the plan in first angle projection. So this is the front elevation. So in first angle projection, the plan is below the front elevation. So what we need to do here now is that from this point here, from this point here, from this point, I will draw a vertical line down here. So draw a vertical line down, and then from this point on this square base, so I will also draw a vertical line, and then from this point here, I will draw a vertical line, and from this point, I will draw a vertical line. All right, so the next thing that we are going to do is that, as we know that the side of the top square here is 64 millimeters, so you still take a measurement of 32 millimeters. So 32 millimeters, so we take 32 millimeters up, so this is 32, and this is also 32. So we draw, a horizontal line, so we make it a thick line, and here also we also draw a horizontal line here, so we make it a thick line. Then I will also make this a thick line. I made this a thick line, and this also will be made a thick line. All right, so I need to show you something. So what I've done here, I've sketched the isometric view of this object for us to know what we are doing. So this is the isometric view of the object. So this is part C as we have here, this is part C, and this is part B as we have here. So this is the isometric view of the object, so as you can see here. So now when you are looking at this object from the top down, you will not see this base, this small square here. You will not see it. It will be hidden from you, so you only see this big square, the top square here. That's what you will see, and that's what we have done here. So this one is going to be hidden. So I want to show you how it is going to look in the plan. To be hidden from us. So don't forget that the length or side of that is 40 millimeters. So take 20 millimeters up and take 20 millimeters down from the center. So here we draw. So this is going to be hidden. So this is going to be hidden. So I don't want to hide anything here. I want you to see how everything is going to be done here. So here now, I will now show this one. I will use short dashes line to show that that part is hidden. Okay, and then all right. And then here, so we show dashes line to show that that part is, that square base here is hidden from it. So that's what I've done there. Then the next thing that we are going to do is that, look at this line. Look at this line. So we are going to see the 4 lines, the first slanting lines. So we are going to see them. So that's what we are going to do here. So from here, you draw this line from this point. So you draw it to the center here. So it stops at the center, and then you can produce this one, then to the center. Also, you produce this. So produce this to the center. So produce this to the center. And then you also produce this to the center. Alright, so that is the plan that we are asked to produce. So we are done with the plan. So I've answered question B, Roman figure 2. I've answered question A and question B, Roman figure 1. So it remains question B, Roman figure 2 now, that says that we should produce the pattern, the complete pattern development of both B and C together. So that is what I want to do now, and I want you to pay attention to what I'm going to do. Then before I draw the pattern development, there is something that we need to do, which is very, very important, and that is we need to determine the true length of this pyramid. We need to determine the true length of this pyramid and the true length of this pyramid. What I mean by that is that whenever a pyramid is positioned, or the base of the pyramid is positioned in this form, this line that we have here is not the true length. This line is not the true length of the pyramid, and this also is not the true length of the pyramid. So what I'm saying is that let's assume that the pyramid is positioned, or the base is positioned in this form. It's positioned like this. The position is turned like this. It's turned in this form. The position is turned in this form. By the time I produce this line, so let me show you. If I produce this line and this line like this, and let's say this is the height of the pyramid, when I join this together and I join this together, this line will be the true length of the pyramid. This line will be the true length of the pyramid. But whenever a pyramid is, or the base of the pyramid is positioned in this form, so just try it and take the measurement. So let's say this is the height of the pyramid, and I join this together like this, and I also join this together. This is not, this line is not the true length of the pyramid. This line is not the true length of the pyramid. So we need to rotate the base of this pyramid. We need to rotate so that it will be in this form. It will be in this form. So this is the true length. Why this one, when it is positioned like this, this is not the true length. So you have to look for a way of getting the true length of the pyramid. So we have to try to turn like this. So I want you to pay attention to the way I'm going to turn it, to how I'm going to get the true length of the pyramid. So I need to extend this line a bit. Okay, so what you need to do is that you take your compass. So take your compass, put it at the center here. Put it at the center here and extend it to this point here. Extend to this point, and you draw an arc. So draw an arc like this. Then after you have drawn this arc, so take this line from here, take it up to this point here. So you touch this point, here. So this point that it touch, so you draw a line. So from here, so draw a line from this point here. Draw a line from this point. So let it pass through this point here. Let it pass through this point. So you draw it. Okay, so draw it to this point, and then I will need to extend it for a reason, so which I'm going to tell you. So extend it here. So the distance that I've taken from here to here, or from here to here, is that distance from here to here. This is the true length. So this is the true length of the pyramid. Likewise, for this one also, because they have the same square base, so this will be the true length. from here to here, it will be the true length of part B. So that is the true length. So this is the true length of part B now. So this is the true length of part B. So that's what we have there. So now the extension that I did to this point is that if I want to complete this pyramid now, if I want to complete it, as I said that this is a frustum of pyramid, so if I want to complete it, so I will just what? I will just extend it to this point. So I'm going to make use of this line from here to here for the surface development. So let's look at the surface development. Right, the next thing that we are going to do here is that for the surface development, so move your T-square up like this and draw a horizontal line. So draw a horizontal line. So this point, I'm going to call this point. So I'll just take a point here. So taking a point here, I will call it point O. So this point O is for this point here. Is for this point. So for the complete pyramid, that is part C. So distance from here to here. So it's going to be the true length. So I will take a distance, this distance from here to this point. So let me call this point, let me call it point A. So let me call it point A. So I will take distance OA like this with my compass. Take distance OA. So this distance like this. Then I will put the pinpoint of compass at this point O here. Then I will draw an arc like this. So I believe you can see the arc. So I've drawn the arc. So I've drawn the arc. So the next thing that we are going to do is that, so we want to open this pyramid. So we want to cut it here and open it. That's what we want to do. Though we are not told, we are not given the seam. That is where the points are joined together. So I'm just going to take a point. So I'm going to take a point from here. I will open from here, and we are going to have 4 of this. That's what we are going to have. We are going to have 4 of this shape. Likewise, this one 4 of this. So let's get that of the surface development of C first. So you take 64 millimeters. This size 64 millimeters. Take it. So put the pinpoint of your compass at this point and make 4 arcs on this. So this is 1. So this is 2. So this is 3. And then so this will be 4. All right. All right, I've redrawn the arc so that we can have the diagram within this place. So I've redrawn the arc. So this is the arc and this is point O here. So the next thing that we are going to do is that take this distance, which is 64 millimeters. So take it with your compass and put it at this point. So we are going to make 4 arcs. This is 1, this is 2, this is 3, and this is 4. Okay, so that is 4. So the next thing that we are going to do is that we are going to join each of these points with point O. So we join them with point O. So there is it. So you join this together with point O. So what I'm doing here is that I'm turning this down. I'm turning it down. So it is more convenient for me to turn it down. So I'm turning it down. So I want this part here to be down. So that's what I'm doing. So and then so we join this together. So So join this with point O like this. So the next thing that we are going to do is that, so this base, so we are going to make it thick. So distance from here to here, so you draw this with a thick line. Then this also, so you draw this with a thick line like this. Then here also, so you also join this together with a thick line, and this also should be drawn with a thick line like this. Alright, so the next thing that we are going to do is that, so take this distance from here to here, this distance from here to here. So take the distance from here to here with your compass, then put it at this point. So you make an arc here. So you make an arc here. Okay. Then you make an arc here. Then you make an arc here. Then you bring it to this point. So you make an arc here. Alright. So after making the arcs, the next thing we are going to do is that we are going to join this together. So you join this point together. So join this together with this. So you join this together with this. So then you join this together with this. Then you join this together with this. Alright, and then so this line we are going to make them thick because it's a pyramid. So we make this line, so make this a thick line. So alright, this is what we have. So the next thing that we are going to do is that we need to, everything that we have here is for part C, which is this one, is for part C. So then part B, we need to put it together with this. So how are we going to do that? How are we going to do that? So what you just need to do here is that you take this distance, which is the true length of pyramid B. So take this distance from here to here. So put it at this point. Put it at this point. Make an arc here like this. So put it at this point. So make an arc here. So they will intersect. Then make an arc here. Then you also make an arc from this point. So make an arc here. They intersect here. Then also make an arc here. And then so put it at this point here. Make an arc, then make an arc here. So make an arc here, then put at this point. So you also make an arc here. So all the points of intersection, so you join them together. So you join them together. So join this together with this, like this, and then you join this together with this. And then so you join this together with this, and then you join this together with this also. So we join this together, so join this together with this, and you join this together with this, then this will be joined together, this, and then so you join this together with this. Alright, so this is the pattern development that we're asked to produce. So if we join them together, if we fold this thing, all these ones also, if we fold these four together, these ones will also come together and to form what we are given here, which is this, which will form this solid shape like this. We form this solid shape. So this is the pattern development of part B and C that we're asked to produce. So this is how the problem can be solved. So as simple as I've done it here. As I said, if you are watching my video for the first time and you're a technical drawing student, subscribe to this YouTube channel so that you can learn more, and put on the notification bell so that whenever I upload a new video, you will be notified. Don't forget to share my video with your friends. Tell them about this particular YouTube channel where you learn technical drawing in a raw form. As you see me using the instrument, you will be able to know how to use the instrument. Thank you for watching and thank you for listening. Don't forget to practice. Thank you. God bless you.